So the next thing we're going to do is perform set operations that involve multiple operations like complement, union, and intersection to find the new sets in the same problem. So we have to have a universal set. So in our example, we have A, B, C, D, E is the set for the union set. A is the set of B and C, and B is the set of B, C, and E. Now we're trying to find A union B complement. So the complement of A union B. So I first have to take this in parts. Do you see that I have to do A union B first? So I'm going to come over to the side of my paper and do A union B. A union B would be everything that belongs in A and or B. So B and C belong in A, B, C, and E, so I'm going to add E, because as long as it belongs in either A or B, it belongs in A union B. Now, if I take that answer and I'm trying to do the complement would be anything that doesn't belong in A union B, but also has to be within the union set, universal set. So what belongs in the universal set but doesn't belong in A union B? Well, A isn't in A union B, B is, C is, D is not, but E is. So the complement would just be everything that's not in A union B. So that's how you would put together more than one set. Let's try another one. We have the complement of A intersect with the complement of B. So I have to do what the complement of A is first. Just like order of operations, I have to do things in the correct order. So A complement would be anything that's not in A. So A has the elements of B and C, so B and C don't belong. So A, D, and E belong in A complement. Now let's do B complement. What belongs in the universal set but not in B? Well, that would be A. B, C, and E are all in B, so A and D. So now I'm going to take A prime and B prime and do the intersection, meaning intersection has to be common in both. So it looks like A is common in both and D is common in both. So that would be A prime intersect B prime. So that's how you put more than one thing together, more than one operation together. Let's give it another example. This time I'm going to give you an example that has a Venn diagram associated with it. So we have the universal set, U, in the box. Then I have the set of A. Now all of the elements that belong in this circle A, we'll do the circle A in green. So anything that belongs in the set A. So A, B, C, and D. Now these Roman numeral 1, 2, and 3, and 4 are just trying to help you understand which regions of the Venn diagrams. It's the lowercase letters that are the elements today, okay? Anything that belongs in the B circle, we'll do an orange, so D and E belong in those. And D is that unique element that belongs in both the A group and the B group. That's why it belongs in the intersection, or the place that overlaps. Then we have elements F and G that belong inside the universal set but don't belong in A or B. So if I'm trying to find A union B, that means it's the set of elements in both A or B, or both for that matter. So which regions am I actually talking about? Well, I'm talking about regions 1, 2, and 3. And in roster notation, that would look like all of the elements of region 1, A, B, C, anything that's in both, and anything that's in B only. So A union B would be anything that belongs in any of the circles A or B. A union B complement, well, A union B we've already talked about as being regions 1, 2, and 3. So the complement would be the one region that doesn't belong. That would be region 4. Okay, what elements belong in that? F and G. The next part, A intersect B. Well, that's the set of all of elements that are both in A and B. So the only region I'm talking about there is region 2. And the set roster notation would be the only element that belongs in there D. Well, what's the complement of A union B? Well, if region 2 is the only thing that belongs in A union B, the complement would be all of the other regions. 1, 3, and 4. So the elements that belong there are basically everything except D. Next, A complement intersect B. This means it can't be an A, so we're talking about everything that belongs outside of the green circle. Intersect. Okay, intersect. That means we have to, all of the things that are not in A but that are in B. So let's see, what is not in A but is in B? So it's got to be inside the orange circle but not inside the green circle. So that is the only region 3 that we're talking about there. And the only element would be E, that would belong in that region that is in B but not in A. How about A union not B? So we're talking about it has to belong inside of A, including anything that's not in B. So anything that's not inside the orange circle, or anything that's in the green circle, or both. So what are those sections? It can be in the green circle, so that's region 1 and region 2, or not B, so that could be region 4, or both. Okay, so I think we have all the regions. And what are the elements there? A, B, C, D, not E, and then F and G. So those can get a little complicated, but the Venn diagram kind of helps you visualize it, especially for those visual learners out there. All right, one last example here. I have the regions 1, 2, 3, and 4 listed again, but all I'm really asking for is the elements this time, okay? So A intersect B. That means it can be an A and it has to be in B. So it has to be in both. The only one there is 5 that's in both. Okay, so A intersect, again that's an and, but we also have a prime here, so that's a not. So basically I can take the answer for A and then not it. So anything that's not in the section with 5. So that's 2, 3, 7, 11, 13, 17, and 19. Okay, union, A union B. That's or. That means it can be in A or it can be in B. So anything that's in A or anything that's in B, everybody's included as long as you belong in those two circles. So 2, 3, 5, 7, 11, and 13. How about A union B? So this is or, but then this is a not. So basically it's the answer to C, but not, okay? So it's the opposite of the answer to C. So anything that's in A or B, but not what it is. So I'm wanting 17 and 19. Those are the only two things that are not in A or B. Okay, so now we have A prime. That's a not. Union with B. Union is or. So we need to figure what's not in A or in B. So what are things that are not in A? The list of things that are not in A are 7, 11, 13, 17, and 19. But it can also be in B. Well, B, I've already listed most of it, 7, 11, and 13. But I also can include 5. Now I know 5 doesn't belong in A prime, but 5 does belong in B, so therefore, because I get to include anything, it also gets to be in there as well. Alright, A and, that's intersection, so that's and, not B. So it has to be in A, and it can't be in B. So what section is in A, but not in B? Well, elements 2 and 3 are in A, but also at the same time are not in B. We can't include 5 because 5 doesn't belong in B prime. 5 belongs inside of B. Okay, n of A prime. Do you remember what this n? This is cardinality. So this is talking about how many elements. Okay, how many elements are in A prime? Well, if we're talking about A prime, let's just list it real quick. A prime is anything that's not in A. So 7, 11, 13, 17, and 19. Those are all of the elements in my picture that are not in A. How many elements are there? 1, 2, 3, 4, 5. So it looks like the cardinality of A prime is 5. All right, again, we're talking about cardinality of A union B. Well, A union B, I've already done that. That's part C, right? How many elements are in A union B? 1, 2, 3, 4, 5, 6. Again, that's the or, right? So when you have the n in front, we're just talking about cardinality. You're talking about how many elements are there. So in that case, you're just listing a number of elements. And that concludes our lesson on Venn diagrams and set operation.